Thank you everyone for joining us for this webinar, An Audio Jack is Not a Jack is Not a Jack, with Jan Van Zyl. My name is Mallory Misnarsic and I'm the project manager here at Harman. A few things before we get started. Everyone on the call is muted to keep down noise levels during this webinar. However, there is a Q&A function where you can submit questions to the presenter and I'll try to answer as many as possible at the end. This webinar will also be recorded and a link will be made available a few days after this presentation. We do have a number of other webinars taking place over the next few months for audio, lighting, video, and control. We encourage you to take a look at the different webinars in our Learning Sessions workshop series on pro.harman.com, as well as visiting Harman Professional Training to see our many on-demand and certification courses that are available to you for free. And now I'd like to introduce you to Jan, the presenter for today's webinar. Jan is a South African sound engineer, experienced in sound system setup, front of house mixing, and radio broadcast. Jan started teaching sound engineering in 2001, developing course content over the years based on extensive research and his own industry experience. And now I'll pass it over to you, Jan.
Thank you very much. I would like to start the session with an anecdote. And this is actually the foundation where I came to the topic, a jack is not a jack is not a jack. In about 2001, 2002, around there, one Friday afternoon, I went back to head office after lectures and to finish up some admin. And I got a phone call. One of our students rented our small sound system and he forgot the mixer. And being a student, I understand, yes, you're not experienced and these mistakes do happen. So the best thing was load the mixer in the pickup, get to the venue and help him out. But as I got to the venue, I realized that maybe I need a bit of extra assistance. I'm not just going to drop off the mixer and go. So I gave him a chance to connect the mixer, set it up, and do the sound check. As he connected his laptop with a mini jack to a dual RCA connector cable to the mixer using RCA to jack adapters, the weird thing happened. It didn't work. There's no sound. So going through fault finding session, we looked at the routing on the desk. It was a Soundcraft Spirit Live 4. We looked at the settings on the laptop sound card, but couldn't find the fault. And then start suspecting the cable. And as we started to unplug the jack with the RCA connector, just one notch out, the sound came in. Put it back in all the way, no sound. Slightly out, so the music is back on. And that was a bit strange. I haven't experienced that before. So as I pulled this cable out with a mini jack, with a RCA to jack adapter, I've noticed it's a stereo jack. It is not the one that we're very familiar with, RCA to normal mono jack, but with a stereo jack. And that was a bit strange. And realized that internally with this adapter, the manufacturer shorted the tip and ring, which didn't at first make sense. And my first reaction to the student was, throw away these adapters. Let's find mono jack adapters in order to do the job, which we did, and the sound system worked. He could play music from his laptop. Later that night, thinking about this, I realized, but hang on. These RCA to stereo jack adapters are awesome. They can actually solve a few problems, especially for the next weekend's gig that I've got booked. So in the next few days, I had to go to all local music stores and bought all the stock of this adapter, which at first I thought, throw away. They're useless. But in the end, they're actually super cool. And this is where I realized a jack is not a jack is not a jack. Our journey for tonight. We're going to have a brief look at the different jack plug variations. We need to look at balanced versus unbalanced connections because that's the key part of understanding what we're going to do. We have to look at the various wiring connections or conventions that we've got for the jack plug and their incompatibilities. And this is where the key lies. Things are not compatible with each other. And understanding the wiring conventions, we can navigate this. And then I'll give you a couple of Macgyver moments. I'll explain Macgyver moments when we get there. So just briefly, the jack block variations. I'm going to refer to tip sleeve and tip ring sleeve jack blocks. So tip sleeve is what we know as the mono jack. But I'm going to stay away from calling it a mono jack on purpose, because there are other connections where we use the tip ring sleeve jack, which is also mono. So to refer to them as mono and stereo could be misleading. So I'll, throughout this session, either talk about a tip sleeve jack or a tip ring sleeve jack. So TS or TRS. So the tip sleeve is what we know as the mono jack, and the tip ring sleeve is what we know as the stereo jack. And our main focus tonight is going to be on these two. Yes, we also get different sizes. If you get the mini jack and the quarter-inch jack, huge difference in size. Everything we're going to talk about relates to both the mini jack and the quarter-inch jack. We get male and female, we get chassis mount, and we get inline. Or again, everything we talk about tonight will apply to both chassis mount and inline connectors. Just to briefly, chassis mount is what is actually built into a unit or a box, and then the inline connector is what's actually attached to a cable. In order to understand where the misconnections or incompatibilities come in, we do have to have a quick look at unbalanced and balanced connections. So the unbalanced circuit only has got two connections. So with our tip sleeve jack, we've got our positive connection, which will be the tip, and the negative connection, which is shared with the ground. And often the cable that we use for the unbalanced connection will have one inner conductor used for positive, and then the screening around that, which is negative and a shared ground. Now, the balanced and unbalanced also apply for XLR connectors. So that's not exclusive to the jack block. If we compare the unbalanced with a balanced connection, with a balanced circuit, we have three connections. We've got a positive, negative, and ground. And because balanced has got three connections, we've got the tip and the ring and the sleeve connector. So we need three separate connection points on the jack block in order to have our three connections. If we compare that with our unbalanced, there's only two connections. And that's where the tip sleeve jack comes in. Only two connections, one for positive and one for shared negative and ground. The advantages of a balanced connection. The most important one, in my opinion, is common mode rejection. That's something we cannot have with an unbalanced connection. So with balanced, we get common mode rejection. So the positive and the negative wires will carry the same signal, but opposite in polarity. And we'll look at a picture just now illustrating that. So we've got the same signal between positive and negative, however, opposite in polarity. That's important. And then the magic of common mode rejection is happening at the input of the receiving device. So obviously the signal we're connecting to the input need to be balanced in order for this to work. And then at the input of the receiving device, the negative signal is polarity inverted so that it can be in phase with the positive signal, and then it is combined with a positive signal. Now, that's also where some of you might have heard where some people talk about balanced connection is 6 dBs louder than an unbalanced. It's because of the combination of the negative and positive voltages, polarity inverted in phase. So we double the voltage, giving us the 6 dB addition. So we invert the polarity of the negative signal, combine it with the positive in phase, and we get double the signal level. So we already have a better signal to noise ratio. But that's not the end. Any noise that is induced into the cable between the sending device and the receiving device will then cancel out. Any noise that is induced equally on both inner conductors, the positive wire and the negative wire, both of them carrying the same noise with the same polarity, will then cancel out. And that's why we call it common mode rejection. Any signal in common will be rejected. And this is a key part to remember when we get to the incompatibilities. So if we look at this diagram, so we've got our TRS jack with our positive, our negative, and a separate ground. So we carry the same signal. You can see it's identical waveform. However, when the one wave is going positive, on the positive wire, the negative wire is going negative. And when the negative wire is going positive, the positive wire is going negative. So perfect invert of polarity between the two wires. And then when we invert the polarity of the negative on the input device, it will be in phase with our positive wire, and we get the addition of 6 dBs. The signal is stronger. However, the noise that is the same, being polarity inverted at the receiving device, will be out of phase and cancel out. And that way, we get much less induced noise in the balanced cable compared to the unbalanced cable. So of all the methods to reduce induced noise, balanced connection for me is one of the most important ones. So some of the advantages using a balanced connection, we get common mode rejection. Very, very important. But we can also use a twisted pair between the positive and negative wires, which will also assist with reducing some of the induced noise in the cable. Just a side note, when we talk about induced noise, we talk about magnetic fields from power cables and other electronic devices, and also capacitively induced noise from lights and other devices. So any of that noise, even RF noise, radio frequency noise being induced, can be, to a large extent, be eliminated with common mode rejection. Another advantage of a balanced connection, we've got the screening separate from the signal carrying conductors. So any noise induced into the screening, which is basically creating a Faraday cage around the inner conductors, that screening is not combined with audio. So we keep that separate. And as a result of all of these mechanisms built into our audio cables with a balanced connection, we can have greater lengths of cables. So to have an 100-meter cable is not the biggest deal because it actually works without too much noise being induced into the cable. If we compare that with an unbalanced cable, the limitations with an unbalanced connection is we don't have any common mode rejection. There's only one positive. There's no negative that we can invert the polarity and cancel out any noise. There's no twisted pair because there's only one inner conductor, not two. The screening is not separate from the signal carrying conductors because the negative is now combined with the screening. So any noise induced into the screening is also combined with the negative part of our audio. So we lose all of the advantages of the balanced connection. So how do we cope with the limitations of an unbalanced circuit? The only solution is let's limit the exposure. And I'm referring to the exposure to electronic noise, electromagnetic fields. We keep the cable away from power cables. We keep it away from noise sources. The other day, setting up for the session and testing my setup here, I got noise on my microphone cable. And when I looked, it was on my laptop power supply. Moved the laptop power supply away, noise was gone. It's exposure. We can also limit exposure by having a shorter cable. So as a general guideline, we say the unbalanced cable should not really be longer than 6 meters. If there's not a lot of noise, electronic noise, electromagnetic fields, electrostatic noise, then obviously, yes, we can have a longer cable. And I have used unbalanced cables of 20 meters or so with great success. But keeping in mind exposure, the placement of the cable. I'm not going to have it next to computers and other power supplies. Keep it separate. So by limiting exposure, we can survive. And then sometimes exposure can also be a problem with balanced cables. Just like I mentioned with my setup testing the microphone. It was balanced and I still had noise. So by removing the power supply, just physically separating the power supply from the audio cable, problem solved. So exposure is not only a problem with unbalanced cables, with balanced, it can also be a big problem. But if you think about the exposure, reroute the cable, you can solve your problem there. Okay, I'm going to, at some point, come back to balanced and unbalanced in order to explain some of the incompatibilities. But before we get to the incompatibilities, let's look at the different wiring conventions. So with the mono jack or the TS jack tip sleeve, it is unbalanced by default because there's only 2 connection points. We do not have the third one. So on the jack plug tip is positive and the sleeve is negative and ground. So tip is positive, sleeve is negative and ground. It is unbalanced. Then we get for the TRS jack, we can wire it unbalanced. And I've seen that many times. If I get called out to venues where they have problems with the system, I find jack-to-jack cables with TRS jacks, and internally they've done this, where they solder the positive to the tip, and they create a short circuit between the ring and sleeve. And by having a short circuit between the ring and sleeve, they effectively convert the TRS jack into a TS jack. The problem is, if you do not open the jack plug or use a cable tester, you don't know. You don't know that this is unbalanced. And I've got into the habit of physically opening up jack plugs at venues just to see what's the wiring inside. Personally, I don't like doing this because it's misleading. It's giving the false impression of being balanced. It can be worse. Sometimes they will connect the positive to the tip and the sleeve and negative only to the sleeve and not to the ring. And on some devices, if internally they're not connecting to the ring, you don't have sound. So this can be a problem. Or sometimes they will only connect to the ring and not the sleeve. Same thing. Depending on the device to which we connect it, it might not make contact. So personally, I say, please do not use a TRS connector for an unbalanced signal, for a mono unbalanced signal. Rather use the TS jack. Then at least whoever is using the cable immediately knows what they're dealing with. Wiring the TRS jack for unbalanced mono signal just does not make sense. Technically, it works. But down the line, it will create some confusion and other problems. Then if we look at the TRS jack for a balanced connection, and this is something we use very often, the line input on mixing consoles, auxiliary outputs, so this is all over the place. All our professional gear where they have used a jack plug, it's most probably the TRS balanced connection. So tip is positive, ring is negative, sleeve is ground. So at no point do we have ring and sleeve connected. The negative is completely separate from the ground. So we can have a proper balanced connection. Then we get the TRS jack wired for stereo. Just going to say again, for the TRS balanced, it's a mono signal. Even though we sometimes call it a stereo jack plug, it's still a mono signal. But wiring it for stereo, it's slightly different. So tip is positive left, ring is positive right, and then sleeve is negative and ground. So this is inherently unbalanced, because for the left signal, tip is positive, sleeve is negative, and ground. For the right-hand side signal, ring is positive, sleeve is again negative and ground. So the moment negative and ground is combined, it is unbalanced. So the moment we use it in a stereo configuration, we have to think about our limitations with exposure to electromagnetic and electrostatic noise. This wiring we find on our smartphones, tablets, laptops, headphone outputs on mixing consoles. So again, this is a fairly common connection. On some keyboards, this is also the only output that we get. It's a headphone and line output. So if we only get this on a keyboard, we need to keep in mind that we need a cable where we can get left separate from right, separate from negative and ground. If we would on a keyboard connect a mono jack plug like we do very often on stages to the stereo output on the keyboard, we will actually short circuit the right positive to ground on the right output, which could actually damage the circuitry of the keyboard. So we need to be careful. So whenever I work with keyboards on stage, I will double check whether it's only a stereo output or two separate mono outputs, and then choose my cabling accordingly. Then the TRS jack for insert connections. The insert connections, we've used that a lot on our analog consoles, and those of you that still use analog consoles might be familiar with this. On our digital consoles, now this is all happening via software, but the concept of the insert is still fairly important. So on most systems where we've got the insert connection, tip is the positive send or the output, ring is the positive return or the input, and then sleeve is negative and ground for both output and input. We use the insert connection to connect additional devices to a mixing console. So if I've got my analog console and there's no compressor on the channel and I would like to use a compressor, I will use the insert connection to add a compressor to the signal path. And I will insert the compressor into the channel to function as if it was built into the desk. This is inherently unbalanced because negative and ground is combined. So the moment we use the insert connection on the desk, we know it is unbalanced. So we think about our exposure limitations. For insert connections, we use a special cable. So we've got a cable that's got one TRS jack going to two separate wires, each going to a separate TS jack. So the TRS jack with the two wires, we connect to the mixing console, to the insert connection, and then the cable where the tip of the stereo jack is connected to the tip is going to the send to the external device. So tip is sending, and then the other mono jack or TS jack, the tip is connected to the ring of our insert cable, the TRS jack, and that will be connected to the output of our compressor. So the TRS jack we connect to the insert connector on the mixer. The one mono jack or TS jack we connect to the input of the compressor, and the other one we connect to the output of the compressor. And a convention I've learned from my mentor, I usually put a bit of red netto tape around the mono jack that is connected to the ring. So the one that is red is connected to the ring, and that is the return. Just a quick, interesting way to explain how the insert connection works, just with another analogy. If a patient is going to the hospital and need to get a heart transplant, they cannot just cut open the body, take out the heart, and let the person die. While they take the heart out and place the new heart into the body, somehow they need to keep this patient alive. So they use a heart-lung machine. So they literally connect the blood that's supposed to go to the heart, going out of the body into the heart-lung machine, then out of the heart-lung machine back into the body. So this massive machine is outside the body. However, it is functioning as if it is inside the body. So we can talk about this heart-lung machine being inserted into the body. That's the same with a compressor. We insert the compressor to a channel to function as if it was built into the channel, even though the unit is physically outside, external to the mixing console. Okay, let's have a look at some of our incompatibilities. And this is where things start to get interesting. If we connect a stereo output, for example, a laptop output, to a balanced input, we've got our TRS jack. This one is now with a stereo signal connected to the laptop. So we've got positive left on tip, positive right on ring, negative and ground on sleeve. And this cable is connected to the balanced line input on a mixing console. The console is expecting positive on tip, it is expecting negative on ring, and it's expecting ground to be separate. But this is not what's happening. We've got positive left on tip going to positive, which is fine. However, positive for right connected to the negative. And this is the problem. This is where common mode rejection is going to give us some challenges. Because common mode rejection is happening with a balanced input. Remember, I've said the common mode rejection is happening on the input side of the receiving device. So what's the result? Anything that is in common between positive and negative will be cancelled out, just like any noise induced into the cable that will cancel out. So the balanced input will cancel out the mono, or everything that is panned in the middle of our stereo music signal, and only the difference, whatever is panned to the sides of our stereo mix, will be heard. And yes, I've been to nursery school concerts where they actually did that. And it's quite a punishment sitting in the audience for a niece's concert when this is happening. You want to run away, because only what you hear is everything panned to the sides. The lead vocal on the song is disappearing, kick, snare, bass, everything's gone. Just hear this mysterious reverb voices to the sides. So this can be fairly embarrassing, making this mistake. So the stereo out cannot be connected directly to a single balanced input. We have to split the signal to two separate inputs. If we do the opposite, balanced output to stereo input, we have a similar challenge. At least here, we do not have common mode rejection fighting us. Because if we have a stereo input, for example, an headphone amplifier, where it's expecting positive left on the tip, positive right on the ring, negative and ground combined, there's no common mode rejection. So at least that's not going to happen. However, a positive going to positive left, negative going to positive right, can create some very interesting sounding results depending on the circuitry. Another example, if we connect a balanced output to a tip sleeve input, and I kind of have mentioned this a little bit earlier, where the tip positive is connected to positive, and if the receiving device connection is only happening deep into the sleeve, connecting to ground, the negative is not making contact. As a student, I bought 2 small powered speakers and very excitedly made a special cable, female XLR to TRS jack balanced, because I've learned balanced is the way to go. And with the female XLR to TRS jack, very excitedly connected to the powered speaker, and no sound. What a disappointment. Just to realize this is the problem. So then I made a short female jack to TS jack cable, where I'm converting the balanced to unbalanced to make sure that the negative and ground is making connection where it should. in order to have sound on those small powered speakers. So the moment I connected the balanced signal to the unbalanced input, no sound, because negative not being connected. Had to make a special cable in order to have the right connection happening. So this is another one that could potentially create some headaches, especially working with someone else's gear. Another incompatibility, if we go back to that mistake that the student made, which I referred to in the anecdote. So let's have a quick look. He had the RCA to jack adapter, where tip and ring was shorted together, both being positive, and the negative and ground being combined. That's the adapter that he used. So the RCA to TRS jack adapter. What's happening on the mixer? It's expecting a balanced signal. The balanced line input on the Spirit Live 4 Soundcraft console expected positive on the tip, negative on the ring, and ground separated. And with the balanced connection, it did the perfect common mode rejection job, where it cancelled out everything that was in common. That was the same. That's not polarity inverted coming into the console. So my positive signal between the tip and ring perfectly cancelled out. And that's why we couldn't hear any sound. And the moment this adapter was pulled out slightly, that the positive is connecting only to negative and the sleeve to ground, then at least we had audio. Then it worked. So the common mode rejection, if we give it the wrong connection type, it will cancel out because it's doing its job like it should. So my Macgyver ideas. I'm a big fan of Macgyver. I grew up watching Macgyver as a kid. And the thing about Macgyver that struck a chord with me is he's using knowledge from proper studying physics and chemistry to solve problems creatively. To use knowledge to solve problems creatively. Now, obviously, the Hollywood element was part of the show, and there's a few things, if you look back as an adult, that is just no way it can happen. Hollywood is Hollywood. However, the concept is still relevant to me. So let me share a few Macgyver ideas with you guys. We can convert the insert connection on the mixer into direct out. Yes, we can use the insert as a direct out on the console. I've done that many times on the Spirit Live 4 console, where the direct out on the console is post-fade and the insert is pre-fade. And if I needed a pre-fade direct out, this is my trick. So for the insert, we make a special cable using the TRS jack to TS jack cable. So we have to create a short circuit between tip and ring. So for the insert, we connect the output directly to the input. The insert output to the insert input. So there's no interruption in the signal path by doing that. And both the tip and ring of the insert side, we connect to the tip on the other end of the cable. And then we use the sleeve as the negative and ground. Remember, it's unbalanced, so that's connected to the sleeve of the other jack. And by making a special cable like this, we can convert any insert to direct out. And this has saved me many times on gigs. But there's a quick fix. Remember, I said to that student, throw away these adapters, but then I went to buy all the stock I could find in the next week. If I use this adapter, tip and ring is already shorted. So if I connect this adapter to the insert connection, the insert is not interrupting the signal path, and I've got a working direct out. And it catches not an RCA connection. But if you have a few RCA to jack cables, no problem. So I've got a couple of these adapters in my toolbox, and if there's a problem and I need to make a quick plan, this is what I do. Converting a direct out from an insert. Another one that I've done a few times on a small digital console where the preamp is still analog. I've had it where the preamp dies, but the analog to digital conversion is still working. And a very faithful small Spirit SX console that I've got, I will use that preamp for the mic and phantom power, take the direct out from that small console into the insert input. But for that, I need the insert cable. And I'll connect the TRS jack to the insert of the connection of the digital console with a faulty preamp, and then the return I'll connect to the output of the small analog desk where I use the preamp. The third connector I just left lying around because we don't use that. So this also saved me a couple of times. With a faulty preamp, use a different preamp, but still get into the right channel and get to use the DSP of the digital console. And then my last Macgyver idea, this is something I did 2 weeks ago, the recording session. If I have to connect the balanced output, like the mixer auxiliary, to a stereo input of a headphone amplifier, or this, I've also done it many installations using small powered computer speakers, because that's more than sufficient with a built-in amplifier and very well priced. So if I've got my balanced output, positive on tip, negative on ring and ground, and I want to connect it to positive left, positive right, what I need to do is have the tip of my balanced output going to both tip and ring of my stereo headphone amplifier. So again, we need a special cable. And then the negative and ground of my balanced connection needs to be connected to ground or the sleeve of my connector going into the headphone amp. So my balanced output is being made unbalanced because the receiving device is unbalanced by default, being stereo wired. But at least now I've got my positive connected to both left and right positive. My negative is connected to the negative of the receiving device, and ground is connected to ground. And with this cable, we can get the job done. But we can do our quick fix, these adapters. So what I've done 2 weeks ago, I've got lots of turnarounds. I've made turnarounds, every type of connector to XLR, male or female. So I took female XLR to RCA, turnaround, auxiliary output into my adapter, and my headphone amp, I've got the same signal both left and right. And my artist was happy during the recording session. Okay, that is basically the story from my side. So we can now open the floor to some questions.
Thank you. It doesn't look like we have any questions yet. We can give it a couple minutes.
Okay.
I do want to thank everyone for joining, and thank you, Jan, for this presentation. It was a great session. We had a lot of comments come in that said they love this presentation.
Thanks a lot. I do hope that this will be useful so that you can also solve problems creatively along the way.
So we do have one question that just came through. It said, can you review the last fix?
The last one was for the headphone amplifier. So small headphone amplifiers typically have got a stereo input, just a TRS jack. And if you've got a mono signal that you want to connect to that from an auxiliary output on the console, you cannot simply use a TRS jack to TRS jack cable. It's not going to be compatible. So one option is to make a special cable where you connect the tip of your mixer, a TRS jack, to the tip and ring of the jack going into the headphone amp. The ring with the negative of the TRS jack on the mixer side, the balanced output that's going to the sleeve of the jack going into the headphone amp, and then the ground, a sleeve to the sleeve on this side. But making special cables like this is not always useful. They will get used the wrong way. They will get mixed up in the wrong application and create more headaches. So quick fix, the RCA to TRS jack adapter, where the positive from the RCA is connected to tip and ring, which is what we want for the headphone amp, and then the negative and ground is connected to the sleeve. So having a couple of these adapters in my toolbox, I can very quickly connect my mono signal from my mixer auxiliary output into both left and right inputs of the headphone amplifier, keeping the artist happy. So
perfect. We did have a couple more questions that did come in. So the next question is, the last Macgyver tip was still only giving a mono feed, correct?
Yes, it is mono, because you might not have enough stereo auxiliary outputs, and that's what happened in this recording session. I've used all the stereo auxiliary outputs where it was critical, and then we had to add just one extra mono output, but I still want the audio to be both sides on the headphones, at least so the artist can still hear on both sides. So for that, yes, it is a mono signal, but at least it's on both sides of the headphones.
Perfect, thank you. The next one is, if we need to connect a small headphone amp that receives signal in XLR, stereo signal, to a mono-balanced XLR, what's the Macgyver solution?
I'm just quickly reading it again. If you connect small headphone amp that receives a signal in XLR. So if it's one XLR, it is balanced mono. So if you talk XLR connectors in stereo, there have to be two XLR connectors that need to be combined into one stereo jack connector. So the moment we talk XLR connectors, it is balanced, it is mono. So if you, and actually for the recording to expect made a few cables with two female XLRs joining together on one TRS jack, so I can get both left and right going into the headphone amplifier.
Perfect. So we do have a handful of other questions that came through. The next one is, I have a few 1/4 mono cables that are designed to be used between instrument amps and loudspeaker cabinets. Why do I get a hum when I use the cables to connect my guitar to the instrument amp?
Okay, so the hum can be a couple of things. There can be a ground loop involved there. So if there's a ground loop, that's something we need to look at, and that's a whole topic on its own. That can be a good 2-hour webinar by itself. Or it could be exposure, can be noise. But also keep in mind, a lot of guitar amplifiers are noisy by default. Why manufacturers make it like that, well, I don't know. I'm not a guitarist, but I've noticed a lot of them happen to be very noisy. Just also keep in mind, between the guitar amplifier head and the cabinet, if it's a loose head and cabinet, you need a speaker cable, not just a normal audio cable. Speaker cable with a thicker gauge wire and no screening. And if you connect from your guitar to the amplifier, it's an audio cable that has to be also unbalanced mono jack to jack cables, but the audio kind of cable. Also, if there's noise, it could be a problem with the pickup on the guitar that I've also experienced with some instruments. If the guitar has got two different pickups and you switch between them, if one is noisy and the other one not, it might be time to send the guitar in for a service.
Perfect. The next question is, how do you suggest labeling these cables so you know what is what?
So on my system, I don't have a lot of these funny cables. I do have a lot of these little adapters, RCA to TRS jack. So that saved me a lot. And then I've got turnarounds, everything to XLR. So here's a female 1/4" jack to XLR. I've got female XLR to female XLR. Sorry about that. And female RCA to female XLR. So with these short turnarounds, I use standard XLR cables for the long runs and just the appropriate turnaround at the end to make the conversion that I want. So I don't have a lot of long, weird cables. It's mainly my turnarounds that where the magic lies. For the rest, standard XLR cables.
Perfect. The next question is, I had issues last time where I plugged my PC to the mixer and the 48V was distorted my PC. Now this adapter does it guarantee safety while using the PC?
Definitely not. The only real solution is use a DI box. If you connect your laptop directly to the mic input where there's phantom power, I've done it myself. I've destroyed a cell phone that way. A lot of us have made this mistake. Rather use a DI box. That's the only way you can guarantee the safety of the equipment. And the DI box will also help if there's any ground loop problems where you can lift the ground on the DI box and eliminate some of the noise that could come from the laptop's built-in sound card.
Perfect. And the next question is, how is the Canary Instrument cables GS4 and GS6?
Never used them, not familiar with that.
Okay.
They can't answer that one.
Perfect. The next question is it possible or safe to send phantom power through TRS connectors?
My opinion, a connector is a connector. Connects anything to anything. For me, the important thing as operator, you need to know what you're doing. So generally, phantom power will only be on the XLR inputs on the mixing console and not the line inputs. And it's done on purpose by the manufacturers because they know that we will sometimes connect unbalanced cables to the line inputs, the jack inputs. So can it work through a TRS connector? Absolutely. But you need to think carefully why you would want to do that and build in safeguards that doesn't create any problems. So even with Neutrik combo connectors that we use on stage boxes, at installations, I might not even connect the jack plug if I suspect there's a chance that a musician might connect a mono jack plug and phantom power going to a guitar, an instrument like that. So that's where I take responsibility and make sure that I prevent any errors like that. Can it go through TRS? Yes. Is it advisable? Probably not.
Great. The next question is, which is the best way to adapt a stereo unbalanced out to a mono unbalanced input, 2 channels to the 1 channel?
The only way, the real way is to have a combining circuit. There are some DI boxes where they have a merge function where you can do that. That's advisable. I think most of us have done it where we just combine the positive of left and right, but most literature advises us against that. So rather use a circuit with a proper circuitry to do that. But I've done it myself, combining positive and negative, positive for left and positive for right together into 1 channel without any problems. But literature says we shouldn't.
Great. The next question is the P2 amp in stereo and have an XLR connector stereo signal. I have the Soundcraft UI24 and want to send 1 aux only to the P2 amp. If I use a regular XLR cable, only have sound on one side of the amp. I'm not sure I fully understand that one. I don't know if you do, John.
Okay, so again, the XLR connector, I haven't seen that being used for stereo signals on any devices. Through my turnarounds, I've done that a few times, but that's doing weird stuff. But on a device itself, I have not seen that. However, I have seen the 5-pin XLR, which then has got a stereo signal. So that amplifier must have 2 inputs, 2 XLR inputs. So there has to be 2 cables from the mixer going into that amplifier in order to get both left and right. If the amplifier has got the TRS jack input wired in stereo, that's a different question for a different answer.
Great. The next question is, you talked about balanced inputs and outputs, but you have electronic balance and transformer balance in and outputs. Are transformer balanced in and output still used? And then there's a second question. Is there a difference in behavior between electronic balance and transformer balanced inputs and outputs?
Okay, so this is now taking to a level of electronic knowledge where I'm a little bit scared to answer. As far as I know, that we don't use a lot of transformer balanced anymore because simply it's heavy. It's bulky, it's heavy to carry and expensive. So we don't see that very often anymore. So most are electronically balanced. But in terms of better or worse, I can't really answer that. It's a little bit deeper electronics than what my knowledge is.
Great. The next question is, if you make a cable, TRS, and 2 XLRs, do you have to bridge out pin 1 and 3? And if you do bridge it out, will phantom power will be a problem on the device you plug the TRS into?
Okay, so I've made these cables specifically for headphone amplifiers to have 2 XLR outputs from my console going to 1 TRS input on the headphone amplifier. So in that case, yes, the 1 XLR pin 2 is connected to the tip of the TRS jack. The other XLR pin 2 is connected to the ring of the TRS jack. And then on both XLRs, I do short pin 1 and pin 3 together. And of both XLRs, pin 1 and pin 3 connected to the sleeve of the TRS jack. The moment you short circuit pin 1 and pin 3, make it unbalanced, do not use phantom power. You will damage your console power supply with phantom power. You will damage the device that is connected to. So the moment you change any circuit to unbalanced, do not use phantom power. It's going to be expensive. You're going to regret that.
Perfect. And the last question we have here is, in studio applications, if you are using oxygen-free cabling, do the adapters decrease the signal quality?
Well, with these adapters being unbalanced, yes, there will be a decrease in signal quality if it was possible to stick to balanced. If your signal was unbalanced already, then I will worry much more about the exposure and routing of the cable than the oxygen-free cabling. The difference the oxygen-free makes is just making the cable last much longer over a 20 or 30-year period. So the oxidation of the copper is not happening. So in terms of degrading quality, it's negligible unless you go from balanced to unbalanced, where it was possible to stay to balanced.
Perfect. We did have one more come in if you have a couple more minutes. The next question is, do you recommend leaving cables connected in a cabinet when transporting?
Yeah, that depends on the quality of connectors. If the manufacturer uses top quality connectors and you do the same, I haven't had major problems with that. However, if it's a long connector and there's lots of weight, then I would stay away from that. If it's just normal XLR or jack, I haven't had problems with that yet.
Perfect. I want to thank everyone for joining. And Jan, thank you so much for your time today. This was a great session. I hope everyone has a great rest of their day.
And thanks very much for hosting us. I really appreciate that. It's an opportunity to share some knowledge.
Perfect. Bye, everyone.